This video is about the buckling of compression members. Compression members carry compression axially through the length of the member, and when they fail, it is often due to buckling. As I load this up in compression, you can see that the middle part of the member is moving sideways. If we listen carefully, we can hear nothing. There's no sound of material failing. It's simply a geometric failure, and when the load goes off, the material straightens again. So it's a geometric failure that's primarily dictated by the modulus of elasticity of the material. The stiffer the material is, the stronger it is in buckling. Now, the slenderness in buckling. As I'm loading this up, you can see that it is always popping either that way or that way there. Always about the minor axis. We call this minor axis buckling because the movement of the member is in the same direction as the smaller dimension in the cross section. If I was to induce major axis buckling into this member, it would move into that kind of a shape. But there's no way I can put enough load in to cause this member to buckle about its major axis. So here is one that I've prepared earlier, and it is buckled into its major axis displacement. Buckling about the major axis will give it this kind of shape. And you can see that the movement is in the direction of the major dimension, the larger dimension of the cross section. So that's major and minor axis buckling. Now the slenderness of a compression member is dictated by the length of the member over which it's buckling divided by the breadth of the member. And that gives us the slenderness of the whole member. If we introduce a lateral restraint into the middle of the member, then we can reduce its slenderness, because now what we've done is reduced the length. The cross-sectional dimension is still the same, and the buckled shape of the member is also going to change, so that as we load it up, it goes into an S shape. And the buckling length is now not the full length of the member, but half the length of the member. And the strength of the member has increased substantially as a result of that. So buckling. Buckling of compression members is all to do with the cross-sectional dimension and the length of the member. The most slender compression members are going to be very long and very narrow. So minor axis buckling is going to be about this axis, major axis buckling about that axis. We work out both slendernesses, and then from those two slendernesses we calculate its k12 factor, its stability factor, and that is incorporated into the capacity equation for the strength of the compression member.